Good afternoon, respected organizer, session chair, researchers, academicians, industry experts, and dear friends. I'm Engineer Aditya Singh, ISTS M.ASC AMIE. I've been an independent researcher, editorial review board member in 6 American international journals: IJSSMET, IJRLEDM, IJESGT, IJSTS, IJDSST, IJPAE, reviewer in 10 American, 6 Singaporean, 1 Indonesian, and 1 Swiss-based international journals, alumni mentor registered by Amrita University Alumni, Amrita Vishwa Vidyapeetham, India, think tank expert, Beijing Zhongzhuan Electric Power Energy Big Data Research Institute, ex-research mentor at Academy Nova World, Kalipur, India, and ex-alumni mentor LPU. Today's the topic of presentation is the sector of built environment requiring artificial intelligence-led transformation through governance models and readiness of organizations. Outline. In today's presentation, we are going to cover introduction, literature review and research gaps, global challenges, built digital transformation, and so on. Introduction, general. The built environment is experiencing one of the most significant technological transformation in the recent decades. AI is increasingly being integrated into planning, design, construction, infrastructure monitoring, facility management, and smart city operations. However, despite rapid technological advances, many organizations still struggle to implement AI successfully. So, in this study, the successful AI adoption depends not only on technology but also on organizational readiness, and effective governance frameworks will be emphasized. Background. The construction and infrastructure sector remains one of the world's largest economic sectors, yet it continues to face persistent challenges such as low productivity, project delays, fragmented information management, cost overruns, safety risk, and inefficient asset management. In the recent years, it has been found that industries have invested heavily in artificial intelligence, building information modeling, BIM, IoT, digital twins, cloud computing, and predictive analytics, where these technologies frequently fail to deliver their expected benefits because organizations are not adequately prepared to integrate them into their operational systems. Recently, it has been discovered that AI readiness demonstrates that digital infrastructure alone does not ensure successful implementation. Leadership commitment, governance mechanisms, workforce competencies, organizational culture, and data maturity consistently emerge as the strongest predictors when incorporating artificial intelligence. Therefore, the focus should be uh, from AI should be adopted to how organizations can prepare themselves institutionally for AI-led transformation. Literature review and research gaps are roughly 50 published papers were considered, and only recently published papers were further taken into account. So there were numerous gaps which were found in those studies. First is the relatively few empirical studies evaluate the long-term effectiveness of AI governance frameworks within construction infrastructure organizations. Then, standardized organizational readiness assessment tools remain limited, making comparisons across organizations difficult. Plus, most published evidence originates from developed economies, while developing countries continue to receive comparatively limited attention despite facing rapidly expanding infrastructure needs. Additionally, research is required to integrate AI governance with digital twins, lifecycle asset management, resilience planning, and sustainability assessment. Now the question comes, the relevance of this study. This study is highly relevant because the built environment is undergoing rapid digital transformation led by artificial intelligence, BIM, digital twins, IoT, GIS, cloud platforms, as well as predictive analytics. Despite these technological infrastructure, Despite these technological advances, international evidence show that AI adoption in construction and infrastructure organizations remain inconsistent and often fails to progress beyond pilot implementations due to inadequate organizational readiness and weak governance structures. The recent systematic reviews, they recognize that leadership commitment, digital infrastructure, organizational culture, workforce competencies, data quality, and governance capability as the principal determinants of successful AI implementation rather than technological sophistication alone. Then it has also been found in the literature that fragmented governance, poor interoperability, and insufficient institutional preparedness continue to limit AI scalability within architecture, engineering, construction, and operations sectors. Then international organizations like Organization for Economic Cooperation and Development, National Institutes, National Institute of Standards and Technology, and International Organization for Standardization have also highlighted the importance of trustworthy AI governance, accountability, transparency, in addition to organizational capability for responsible AI deployment. So through this study, it will integrate organizational readiness as well as AI governance into a unified conceptual framework in the context of built environment. Plus, it will address the gap in the current literature by emphasizing that sustainable AI transformation depends not only on technological innovation, but also on institutional preparedness, interdisciplinary collaboration, as well as governance maturity. Global challenges in built environment, digital transformation. The built environment faces several interconnected challenges, which includes productivity growth, which has remained considerably lower than many other industrial sectors. Then infrastructure projects often involve multiple stakeholders working with disconnected information systems, resulting in fragmented decision making. Plus, data are frequently stored in incompatible formats, creating interoperability problems between BIM platforms, sensors, GIS databases, in addition to project management software. Then another significant challenge concerns governance. Many organizations invest in AI technologies without establishing policies governing data ownership, accountability, ethical decision making, cybersecurity, in addition to regulatory compliance. So then additionally, it has been found that organizations often complete successful AI pilot projects but fail to scale them into routine operational practice because of organizational readiness remains insufficient. So these challenges highlight that the governance uh, readiness is also significant. The need of AI-led transformation. The question comes why AI-led transformation is necessary. AI offers transformative capabilities throughout the infrastructure lifecycle, which includes during planning, the artificial intelligence supports site selection. It can also help in the transportation forecasting in addition to urban growth prediction. Then during the design, ML and generative algorithms will be able to optimize structural configurations and enhance engineering decisions. Then in the case, then during construction phase, computer vision could automatically detect safety violations and help in monitoring progress in addition to identifying quality defects. Then during operational phase, AI analysis could help in the collected data through sensors, which could be used to predict structural deterioration and recommend preventive maintenance before failures occurs completely. Then it could also be said that infrastructure owners increasingly integrate AI with digital twins, IoT networks, GIS platforms, and predictive analytics so that real-time decision making could be permitted. These technologies collectively shift infrastructure management from reactive maintenance toward predictive and preventive asset management, which improves resilience, sustainability, in addition to operational efficiency. Organizational readiness. Although AI technologies continue to improve rapidly, organizations differ significantly in their capacity to implement them successfully. The organizational readiness refers to the capability of an institution to adopt, manage, in addition to sustain AI technologies effectively. So the current literature commonly categorizes readiness into several dimensions, which includes technological readiness that comprise of digital infrastructure, cloud computing capabilities, cybersecurity, and high-quality data. Then organizational readiness, which includes executive leadership, strategic planning, financial investment, and organizational culture. Then human readiness, which also concerns workforce competencies, AI literacy, and continuous professional development. Then governance readiness, which involve ethical policies, accountability mechanisms, transparency, in addition to regulatory compliance. So studies consistently highlight that organization processing strong readiness across these dimensions achieve higher implementation success than organizations investing only in technology. Methodology from the year 2000 to 2025, the global research on the transformation led by AI in the context of built environment through governance models were considered. Then case studies were synthesized, which included Italy, UK, Finland, and Singapore. Then these case studies were connected to AI-led transformation, where governance models were considered for effective frameworks. AI governance models. AI governance refers to the policies, institutional arrangements, standards, and oversight mechanisms that ensure artificial intelligence operates responsibly and safely. Governance exists at several interconnected levels. At the project level, governance focuses on data quality, model validation, and operational monitoring. Then, at the organizational level, governance includes executive oversight, AI steering committees, ethics boards, and enterprise risk management. Then industry governance introduces professional standards and certification systems. Plus, national governments increasingly develop AI strategies addressing regulation, accountability, and public trust. Then international organizations are also establishing global principles emphasizing fairness, transparency, human oversight, in addition to accountability. So, without governance, organizations expose themselves to risk associated with biased algorithms, cybersecurity vulnerabilities, regulatory non-compliance, and loss of stakeholder confidence, as AI often make mistakes. So, human oversight and governance models are essential. Case studies. In the United Kingdom, national digital twin initiatives showed how standardized data sharing frameworks and collaborative governance could improve infrastructure planning in addition to lifecycle decision making. Then, in the case of Singapore, the integration of AI, GIS, digital twin, IoT, and BIM across urban infrastructure through government-led governance mechanisms. So this integration could improve maintenance prioritization, resource allocation, in addition to sustainable planning. Then, in the case of Italy, digital twin applications for public buildings illustrate how organizational coordination and data governance improve facility management as well as operational efficiency. Then, in the case of Finland, the emphasis on technological capability alone does not guarantee successful AI adoption. Leadership commitment, institutional culture, organizational learning, and governance structures are equally important. Built environment sectors requires AI-led transformation. After understanding why organizational readiness matters, the next question is where AI can create the greatest value within the built environment. The built environment encompasses the complete life cycle of infrastructure, which includes urban planning, architecture, engineering, construction, transportation, utilities, facility management, as well as disaster risk reduction. It has been found that AI adoption is expanding across early phase of this life cycle in recent years. In urban planning, AI supports land use optimization, population forecasting, traffic simulation, and spatial planning by integrating GIS with machine learning models. Then in construction management, AI is increasingly used for schedule optimization, cost estimation, productivity forecasting, safety monitoring, and automated quality inspection using computer vision. Then within structural engineering, AI supports structural health monitoring through continuous interpretation of sensor data, which enables early detection of damage and supports predictive maintenance strategies. Then in transportation agencies, it employs they employs AI to optimize traffic management, improve public transport operations, and support intelligent transportation systems. Then utilities are integrating AI for energy demand forecasting, smart grid management, and predictive maintenance of water and power infrastructure. Then facility managers increasingly rely on AI to optimize building operations, reduce energy consumption, and improve occupant comfort. Then disaster management authorities are applying AI to flood forecasting, earthquake damage assessment, wildfire monitoring, and infrastructure resilience planning. Emerging technologies supporting AI transformation. So it could be said that AI really operates independently and it functions as the analytical layer within a broader digital ecosystem. So digital twins here provide continuously updated virtual representation of physical infrastructure assets. By integrating real-time operational data, they enable engineers to monitor asset conditions, simulate future scenarios, and evaluate maintenance strategies before interventions occur. Then IoT serves as the primary data acquisition mechanism. The sensors installed on bridges, buildings, roads, and utility systems continuously collect information regarding structural behavior, environmental conditions, traffic patterns, and operational performance. Then, building information modeling (BIM) contributes structured engineering information through planning, design, construction, and facility management. Then GIS provide spatial intelligence that supports infrastructure planning, disaster management, environmental monitoring, and transportation analysis. Then cloud computing enables organizations to integrate data from multiple departments while supporting scalable computational resources required for AI applications. Then predictive analytics transforms historical and real-time information into forecasts that support proactive maintenance and resource allocation. Then decision support systems combine AI outputs with engineering expertise, enabling managers to compare alternatives and make transparent, evidence-based decisions. Then measurable benefits. Operationally, AI accelerates decision-making by processing large data sets that would otherwise require significant manual effort. So predictive maintenance allows infrastructure owners to detect deterioration before failure occurs, reducing emergency repairs and minimizing service disruptions. Then computer vision systems automate quality inspection and safety monitoring on construction sites, improving compliance while reducing inspection time. Then, from an economic perspective, organizations report reductions in operational cost, improved resource allocation, and better lifecycle asset management. Then, environmentally, AI contributes to sustainability by optimizing energy consumption, minimizing construction waste, improving material utilization, and reducing greenhouse gas emissions. Strategically, AI improves organizational resilience by enabling adaptive responses to changing environmental conditions and emerging risks. Barriers. The first category of barriers in adopting AI is the technological one. Many organizations continue operating legacy information systems that cannot communicate effectively with newer AI platforms. Poor interoperability and fragmented databases reduce the quality of AI predictions. Then there's organizational barriers. The leadership commitment varies considerably among organizations, and many institutions lack comprehensive AI strategies. Employees may also resist digital transformation because of uncertainty regarding changing job responsibilities. So, successful AI implementation requires engineers, managers, and decision makers possess sufficient digital competencies to understand AI generated recommendations and integrate them into organizational workflows. Then there are governance challenges also. Many organizations have not established policies defining accountability for AI generated decisions, data ownership, cybersecurity responsibilities, or ethical oversight. Then financial considerations influence adoption decisions. AI implementation requires investment not only in software but also in workforce training, digital infrastructure, governance mechanisms, and organizational change management. Ethical, legal, and governance challenges. Many advanced AI algorithms function as black boxes, making it difficult for engineers and regulators to understand how particular recommendations are generated. Accountability is another critical issue, apart from transparency. So, when AI contributes to infrastructure decisions affecting public safety, responsibility cannot remain ambiguous. Organizations require clearly defined governance structures identifying decision makers and oversight responsibilities. Then there's problem of bias and fairness. AI models trained using incomplete or unrepresentative data sets may unintentionally produce inequitable or technically inappropriate outcomes. Plus, there's also a problem of normalization, which affects some particular cases which are non-standards. Then there's problem of privacy, which presents additional challenges because digital twins and IoT systems continuously collect operational information, some of which may involve sensitive infrastructure or public data. Then cybersecurity is equally important as infrastructure becomes increasingly interconnected. Protecting AI-enabled systems against cyber attacks become essential for national resilience. Consequently, international AI governance frameworks consistently emphasize transparency, explainability, fairness, accountability, cybersecurity, human oversight, and regulatory compliance as foundational governance principles. Then, organizational readiness framework for AI transformation. Proposed readiness dimensions include leadership. Leadership readiness involves executive commitment, strategic planning, and organizational vision. Then technological readiness focuses on digital infrastructure, cloud computing, cybersecurity, interoperability, and data quality. Then there's workforce readiness, which concerns AI literacy, professional development, interdisciplinary collaboration, and continuous learning. Then financial readiness reflects on organizations' capacity to invest in digital transformation while sustaining long-term implementation. Then governance readiness, which includes ethical policies, regulatory compliance, risk management, auditing mechanisms, and accountability structures. Then there's ecosystem readiness, which recognizes that infrastructure projects involve governments, consultants, contractors, technology providers, researchers, as well as local communities. So only when these dimensions develop together can organizations successfully implement AI at scale rather than limiting adoption to isolated pilot projects. AI governance model for built environment organizations. The proposed governance model adopts a multi-level perspective. At the operational level, governance focuses on project execution, model validation, and data management, which is level one. Then At the organizational level, executive leadership establishes AI policies, ethics committees, cybersecurity protocols, and enterprise-wide governance mechanisms, which is level 2. Then sectoral governance includes professional engineering standards, certification frameworks, and industry best practices that promote consistency across organizations, which is level 3. Then national governance provides legal frameworks, AI strategies, procurement, regulations, and public sector oversight, which is level 4. Uh, International governance incorporates globally recognized principles and standards developed by organizations such as International Organization for Standardization and National Institute of Standards and Technology, supporting interoperability, trustworthy AI, and cross-border collaboration. So these governance layers are complementary and reinforce one another to ensure responsible AI deployment through the infrastructure lifecycle. Results and discussion. The built environment market globally, it could be seen in the year 2024 that the market value was 33 billion US dollars, but it is expected by year 2033 reach 55 billion US dollars. So it could be said that in the span of 9 years, it is expected to increase by 22 billion US dollars, which is a significant rise, and it is uh, approximately around over 1.6 times the increase. So it could be said that the built environment have a bright scope market value wise in the coming years, and it is necessary that the governance models could be uh, focused on so that AI-led transformation could be incorporated in an effective way where organizational readiness could be emphasized. In market growth of AI in digital transformation in figure 2 could be seen in the year 2025. Uh, it is having the market value as 424 uh, billion, over 424 billion US dollars. But in the year 2030, it is expected to reach over 1.6 trillion US dollars, which could be said that it is almost 4 times the increase in the coming 5 years. Uh, in the coming 5 years, which is a rapid increase. So AI transformation will be observed more in the coming 4 years, but the organizational readiness must be highlighted so that the AI-led transformation could be uh, used in an efficient way, so that uh, the initial benefits which were uh, thought about before the implementation could be achieved later on after its incorporation. Then policy recommendations. Government should establish sector-specific AI governance policies, promote open data standards, and support workforce deployment through digital skills initiatives. Then infrastructure organizations should conduct organizational readiness assessments before implementing AI technologies, ensuring that governance, workforce capability, and digital infrastructure mature together at the industry level. At the industry level, industry should establish interdisciplinary AI governance committees responsible for ethics, cybersecurity, regulatory compliance, and risk management. Then, academic institutions should integrate AI governance, digital engineering, and responsible innovation into engineering curricula while strengthening collaboration with industry. And professional engineering societies should develop standards, certification programs, and guidance documents that support trustworthy AI implementation across the built environment. In future, the future research directions uh, should investigate how human expertise and AI can collaborate effectively rather than viewing automation as a replacement for engineering judgment. Conclusion: the built environment is entering an era in which artificial intelligence will increasingly influence planning, design, construction, operation, maintenance, and infrastructure resilience. However, it has been found that throughout this study, the focus had been on not only focusing on technological innovation because it will be insufficient. So successful AI transformation depends on organizational readiness, leadership commitment, workforce capability, governance maturity, high quality data, and institutional collaboration. Then the gaps in the current literature were covered through this study, and some major global case studies were taken into account to highlight how governance models and organizational readiness uh, is vital. Then market growth and future scope of organizational readiness and governance models were considered when AI-led transformation in the context of built environment was taken into account. Thank you.